Hey everyone, welcome back to our centripetal force lesson. Here we are going to finish up this lesson. We have to finish up this question and one more, and then we are done this lesson. So in the previous video we had looked at finding our centripetal acceleration for the given question, and we were so close to being done. We had just identified our two sig figs, or our sig figs for each of the values, and now we can actually go ahead and plug that into our calculator. So you're going to go 8.29047 divided by 0.000014133 into your calculator. What you should get is 586,603.69, and that's a bit of a rounded value there. If you guys chose to keep all of it into your calculator, well, you will get a slightly different answer, but when you account for sig figs, you'll actually end up with the exact same answer, which is fine. So in this, in the numerator here, we had 3 sig figs. In our denominator, we had 4. So that means that our answer has to have 3 sig figs there. Okay. So the 6 here is significant, meaning our answer is 587,000 for our acceleration. That is a big value, so we are also going to convert that into scientific notation. So that is equal to 5.87 times 10 to the power of, we're moving the decimal once, twice, 3 times, 4 times, 5 times, so we have to the power of 5. Next, we also do need to account for our units. So for acceleration, our units are meters per second squared. So the last thing that we're going to do, just to finish off this question, is we do need to write a sentence. So I'm going to very awkwardly write it right along here just because I am all out of space. So the centripetal acceleration at the tip of the blade is 5.87 times 10 to the power of 5 meters per second squared. Alright, so let's move on to our last example. And so this one here, we're going to use that centripetal force equation that we had come up with in the previous video. So a 454.0 gram mass attached to the end of a 1.50 meter rope is swung in a horizontal circle with a frequency of 150.0 revolutions per minute. So here we're going to determine the centripetal force acting on the mass. So this one here, once again, we are going to write down all information here. So here we're told that we have some sort of object, and it has a mass of 454.0 grams. So notice there that the units are in grams, so we do want to convert that to kilograms. So we're going to divide that by 1,000. So we would get 4540 kilograms. Next, we are told that the end of the rope is 1.50 meters, so that tells us what our radius is. And we know it's swung with a frequency of 150 revolutions per minute. So just like what we saw in the last video, we do want to make sure we convert those units. So we want to make sure that we are working with revolutions per second. So when we convert the frequency to period, our units will be in seconds. So once again, we are going to use unit analysis to simplify this. So we have 1 minute in the top to get rid of our units on the bottom, and then we're going to introduce that 60 seconds. So we have 1 unit on the top, 1 unit on the bottom, And so we are going to divide these two values. So you have 150 divided by 60. And that should give us a value of 2.5. And then just to make sure I'm accounting for sig figs here, there was 4 here, so I'm going to put 2 zeros at the end here. And so this is revolutions per second. And then just awkwardly off to the side here, I am going to look at our periods. So that is 1 over your frequency. So that is 1 divided by this 2.500, which gives us an answer of 0.4000 seconds for our units. So now that we have all of our information written down, we've converted to the proper bits of information that we need. Now we can go ahead and look at the centripetal force equation. So as I brought up in the last video, our centripetal force, this new equation without speed, is 4 pi squared times your mass times your radius, all divided by your period squared. So let's go ahead and plug in our information. So we have 4 times pi squared times your mass, which is 0.4540, times your radius of 1.50, and that is all divided by your period squared, so 0.400 squared. So next what you guys can do is, you have your two options. You can either plug this all into your calculator all at once. Just be careful that this square only applies to the pi. And what I'll do in the video is I'm going to do my numerator, do my denominator, and then I will simplify my answer afterwards. So I'm going to plug in 4 times pi squared times 0.4540 times 1.5 into my calculator, and I end up with 26.884. And just considering my sig figs here, I have 4 in my mass, 3 in my radius, which means that my answer is going to go to 3 in total. Now I'm going to do my denominator, so I have 0.400 squared, gives me 0.16, and then I'm going to add in 2 zeros afterwards just to account for my sig figs. Alright, so now I'm going to divide these two numbers. I'm going to plug that into my calculator, and you should get 168.025. And then just to account for my sig figs here, I've got 3 in the numerator, 4 in the denominator, so my answer should have 3 there. So my centripetal force will be equal to 168, and my units there are newtons. Then just to finish this up, we are going to write a sentence. So the centripetal force acting on the mass is 168 newtons. Alright, and so the rest of this is the on your own practice. So if you guys want to, your answers are at the bottom of your worksheet, and there's also detailed solutions on the website. So but please make sure, do try them out on your own, so that way you are getting that understanding and kind of getting that thinking going through your head. And if you guys do have any questions on this or any of the other lessons, homework assignments, make sure, please do send me a message on Remind, and I will get back to you as soon as I can. But thank you guys so much for watching this video.